Imagine I give you two healthcare AI systems. One is 95% accurate. The other is 99% accurate. Which one would you rather deploy? Most people would probably choose the 99% system. I probably would too if that were all I knew. But now let me give you one more piece of information. The 95% system can recognize when it encounters a case it should not handle. When that happens, it doesn't guess and it doesn't simply continue. It defers. The 99% system can't reliably do that. It performs extremely well most of the time, but when it encounters a case where its assumptions don't hold, important information is missing, or the situation falls outside of the conditions where it performs well, it proceeds anyway. Now, which system would you rather deploy? I think that question exposes something important about the way we're evaluating AI in healthcare and other industries. We spend a lot of time asking how accurate a model is. What is its sensitivity? What is its specificity? How does it perform against a benchmark? How often does it hallucinate? Those are all important questions, but they're mostly questions about capability. They tell us how well a system can perform a task under some set of conditions. Once AI enters an actual healthcare workflow, another question becomes just as important. Should this system be allowed to act in this particular situation? I think of that as an admissibility problem. And I don't think this is an AI safety problem, or not just an AI safety problem. It's also an economic problem. Because if we get this wrong, the cost of review, the exception handling, and rework can eat away at the ROI we expected from automation in the first place. Accuracy is not deployment readiness. Let's make the distinction simple. Suppose an AI system is extremely good at performing a task. Maybe it's classifying information, interpreting record, recommending an action, routing a case, or making a decision. It might be right 95% or 99% of the time. That's useful information, but before I deploy it, I want to know something else. It's accurate under what conditions? And then I want to ask, can the system recognize when those conditions no longer hold? Healthcare isn't a fixed environment. Information can be incomplete. Patient may differ significantly from the population represented in data. A laboratory result may still be pending. A workflow may have changed. The evidence available to the system may be sufficient for one action and completely insufficient for another. So even if a model performs extremely well overall, that doesn't automatically mean it should act in every case it encounters. Accuracy asks whether the system can get the answer right. Admissibility asks whether this is a situation where the system should be answering, recommending, or acting at all. Those are different questions. I didn't originally arrive at this idea through AI governance. My background is in biomedical engineering, and during my Ph.D. research, I studied movement planning and how behavior changes around boundaries. One idea from that work has stayed with me for a long time. You can't always understand performance just by looking at the goal you're trying to achieve. You also have to understand the error tolerance around that goal. As the consequences of an error increase, competent behavior should change. The objective may stay the same, but the way you behave near a boundary should not. I found myself coming back to that same idea with AI. We tend to focus heavily on whether an AI can achieve an objective, but capability also needs boundaries. There need to be conditions where the appropriate response is simply don't proceed. Not because the AI is generally bad, and not because the technology doesn't work. It's because this particular case falls outside the conditions where autonomous action is appropriate, and taking action here is high risk. That's what makes admissibility interesting to me. The difference between I can and I should. There's a fundamental difference between I can perform this action and I should perform this action right now. Humans understand this fairly intuitively. If you're a clinician, an engineer, a pilot, or really any kind of expert, expertise isn't just knowing what to do. Part of expertise is recognizing when the situation no longer fits the assumptions behind what you normally do. Sometimes you proceed, sometimes you gather more information, sometimes you ask someone else, and sometimes you just stop. That's part of competent behavior. With AI, though, we tend to evaluate the first question very carefully. Can it perform the task? We spend much less time on the second. Can we determine when it shouldn't? As AI systems become more capable and participate in increasingly consequential workflows, I think that second question becomes much more important. And this is where the problem becomes economic. Let's put some numbers around the problem. Suppose a healthcare organization deploys an AI workflow across 1 million cases per year. For simplicity, let's assume the system is 99% accurate, and that accuracy maps directly onto the decisions we're interested in. Real workflows are obviously more complicated than this, but I want to make the economics visible. A 1% error rate means 10,000 cases where something goes wrong. The obvious response might be, fine, we'll keep humans involved. But now we have another problem. The organization doesn't necessarily know which 10,000 cases are going to be wrong. So suppose it sends 5% of all cases to human review as a safeguard. That's 50,000 reviews. If each review takes only 10 minutes, you're already at more than 8,300 hours of human work per year. Now let's use a simple blended, fully loaded labor cost of $100 an hour. You can substitute whatever number is appropriate for your own organization. That's roughly $830,000 a year just for review. And we haven't even dealt with the cases that slip through. Suppose 2,000 of those cases create meaningful downstream rework, and each one consumes an average of 30 minutes across clinicians, operations staff, patient outreach, record correction, investigation, or some combination of those activities. That's another 1,000 hours of work, roughly another 100,000 at the same blended labor cost. We're now approaching $930,000 in review and rework. And that still does not include delays, appeals, lost capacity, reputational damage, patient harm, downstream financial consequences, or the cost of figuring out why the error occurred in the first place. Again, these are illustrative numbers, not an industry benchmark. The point is the mechanism. A 99% accurate AI system can still be expensive if you can't identify the 1% before those cases create work downstream. Rework is the part we often don't count. This is one of the things I think gets glossed over in AI business cases. We measure how much work AI performs upfront, but the organization ultimately pays for the whole workflow, not just the first pass. Suppose AI saves 10 minutes at the beginning of a process, but an incorrect output later creates 20 minutes of investigation and correction. You didn't necessarily automate that process. You may have just moved the labor somewhere else. In fact, you may have made the workflow more expensive because now the error has to be discovered before anybody can fix it. So I think the business question needs to change. Instead of asking, how much of this workflow can AI automate? Ask, how much of the workflow can AI complete without generating expensive downstream exceptions and rework? That's a much more meaningful measure of automation. The economic value is not simply the labor removed from the first step. It's closer to net AI value equals the value of automation minus the cost of review, exceptions, rework, and failure. That's a number I would want to understand. This also exposes a weakness in one of the most common answers in AI governance. We'll keep a human in the loop. Okay, which cases? If your AI touches 1 million cases, are humans going to review all 1 million? If they are, then I have questions about how much economic leverage that AI is really producing. But if they're only reviewing 20,000 or 50,000 cases, how were those cases being selected? That's where the real problem begins. There are two bad extremes. At one extreme, you review too much. Humans check nearly everything because you don't trust the system enough to operate independently. The technology may be impressive, but much of the economic benefit disappears because you're still paying people to supervise the work. At the other extreme, you review too little. You maximize straight-through automation, but inappropriate decisions pass through and create expensive downstream corrections. Neither extreme is particularly attractive. The real opportunity is to get much better at allocating authority. Where can the AI safely keep moving? Where is more information needed? Where is human judgment actually worth paying for? Where should the system simply not continue? If we can answer those questions well, we may actually be able to automate more, not less. And that's why I don't think admissibility is simply a safety mechanism. It can be an ROI mechanism. So, what would admissibility actually look like? A useful starting point is to stop treating AI as though it has only two possible outcomes, right or wrong. When an AI encounters a case, I think there should be at least four possible operational responses. The first is proceed. The system has the information it needs, the case fits the conditions where it's intended to operate, and the proposed action is appropriate. Let it move. The second is defer. Something is missing, or the current situation doesn't support autonomous action yet. Maybe a laboratory result hasn't arrived. Maybe another process has to occur first. Maybe the record is incomplete. The third is escalate. The AI can still contribute information, but this particular case requires judgment beyond what should be delegated to it. Bring in a clinician, reviewer, supervisor, or another appropriate authority. And finally, stop. The system has moved outside its operating boundary. Continuing is no longer appropriate. Proceed, defer, escalate, stop. Those aren't secondary features to me. They are part of what reliable AI deployment should look like. And notice what happens to the economics. If the system can identify the cases that are appropriate for straight-through automation, humans don't need to review all of them. If it can identify where information is missing, that information can potentially be gathered before an expensive error propagates through the workflow. If it can escalate the right subset, scarce clinical and operational attention goes to the cases where human judgment actually has value. And if it can stop inappropriate actions before they move downstream, you reduce the cost of cleaning those actions up afterward. That's why I think the governance question and the ROI question eventually become intertwined. The objective is not simply to put more controls around AI. It's to become precise enough about where control is needed that you can confidently automate everything else. We need a different definition of good AI. The best healthcare AI may not be the system that answers the highest percentage of questions. It may not be the system that acts in the greatest number of cases. And it may not even be the model with the highest aggregate performance score. The better system may be the one that performs extremely well and recognizes where that performance should be trusted. That's a different standard. Instead of asking only how capable is this AI, we should also be asking, where is it appropriate for that capability to be exercised? For this case, with this information, under these conditions, and given the consequences if it is wrong. And when those conditions are not met, what happens? Does the system proceed? Does it defer? Does it escalate? Or does it stop? I want to make one thing clear. The goal here is not to make healthcare AI more conservative. I think the opportunity is almost the opposite. If every AI decision requires human review, we're never going to get the leverage our organizations expect from automation. But if everything gets pushed through autonomously, eventually the cost of mistakes, exceptions, and rework catches up with us. The economic advantage comes from knowing the difference. Where can AI operate independently? Where does a human genuinely add value? And can we identify those cases before the organization has to pay to clean up a bad decision downstream? That's why I think admissibility matters. It's not simply about building AI that knows how to act. It's about designing AI systems and workflows around the conditions that determine whether they should act at all. And if we get that right, we can do something much more valuable than simply build more accurate healthcare AI. We can create more economically productive AI, more of the right work completed automatically, less unnecessary human review, and less of the savings being handed back through exception, handling, and reward. But most importantly, we allow for patients to get better care. If you want to go deeper into this, I've written a companion article for the Decision Cortex, where I lay out a more detailed framework for delegated authority, human review, false passes, blast radius, and the economics of AI deployment. I'll put the link in the description. Because ultimately, the question isn't just whether your healthcare AI is 95% accurate or 99% accurate. The question is, does it know when it shouldn't proceed?